Okay, question 1C, graph question. This is my favorite as usual. The graph of y equals sine square plus sine to the 4 plus sine to the 6 plus sine to the 8 is sketched in where? Cool. Okay, so let's have a think. Well, what immediate observations can we make here? Well, the first observation that I made is that these are all even pairs of sines, right? So definitely, no matter what the value of sine x is, y is going to be at least 0, yeah? Y would be non-negative, right? Because it's even powers of sines on the right-hand side, yeah? And you're adding them. There's no subtraction even. Yep, okay, so therefore you already know straight away that E is silly, right? Because it has something on the negative side of things, these two chunks, which are silly, yeah? It doesn't make sense. Okay, what other observations could we make? Can y ever be 0? Oh, it could, right? Because if you pick like x is 0, then all the sine x's will be 0, so no matter what power you put them to, it's still going to be 0, right? And you're adding so many zeros, so A is also silly, right? It has no x-intercepts at all. Right, so A is bad. Cool. So, last three graphs. What distinguishes B, C, and D? So I think the most distinctive feature is that for D, there's some sort of asymptote going on, maybe? Like, there's this broken here, the graph. Yeah, maybe there's some asymptote going on. So let's check the value of negative 90 degrees and 90 degrees to see what happens there, yeah? So when x is 90 degrees, well, then sine 90 is 1, yeah? So 1 squared is 1, 1 to the 4 is 1, 1 to the 6 is 1. Okay, fine. So it's 1 plus 1 plus 1 plus 1 plus blah, blah. And of course, the series doesn't converge, yeah? Because you have infinitely many ones adding together. So therefore, at the values 90 and negative 90, it should go to infinity, right? You're adding infinitely many ones. So I think the answer would be D there. All right, quite a fun question.